Dear participants, welcome to the last session of Tech Week. Thank you for joining us on this webinar with the topic ENC Tools, What's New? First, let me introduce myself. My name is Alexander Kramer and I am Sales Manager at 7Cs. After studying industrial engineering here in Hamburg, I worked for a tugboat company for 9 years and recently switched to 7Cs. Our main expert is Friedhelm Mogart-Kegeler. Friedhelm's educational background is geodesy, hydrography, and he holds a degree in both fields. He joined 7Cs in 2000, and ever since, he has worked in various different positions. His long list of activities ranges from S57 data production and training, customer support, research and development, to product management. Today, his activities focus on the development of product strategies and solutions. Friedhelm has long-term experience and specialized knowledge and expertise in the domain of electronic chart production and has expert knowledge about relevant IHO standards. He regularly represents our company at IHO working groups, meetings, industrial conferences, and exhibitions. Our second expert today is Paweł Kaprichewski. He is also a hydrographer and is responsible for the 7Cs customer support department. He will assist our expert with incoming questions. Together, they are our webinar's dream team. This webinar will be recorded and later offered on our YouTube channel. Questions can be addressed during the session in the questions section. Some of them will be answered at the end of the webinar. Remaining questions will be handled after the session by email. So enjoy the webinar and drink a digital beer or coffee.
Yes, Alexander, thanks for the introduction. I also would like to welcome all attendees. Good morning, good afternoon, and good night, as far as I recognized. We have guests from all over the place. Today's is the last session, unfortunately, and we enjoyed it very much. We did previous sessions during the last day, during the last days from Monday on. And the session of today is called ENC Tools, What's New? Well, you probably know ENC Tools is a group of chart production tools 7Cs provides. First, I would just like to give you an overview and so that we can see what are the topics we will be talking about. So I think you find them interesting from the first to the last one. We'll start with some new IHO standards, focusing on those that have been relevant to us when we worked on our ENC production tools. What I would also like to do is to provide you information, news on our ENC tools, and do some demonstration about new features and functions. Then there have been discussions on the incorporation of high-density bathymetry in electronic charts on IHO working group level. And I would like to introduce our solution to this problem. So I will do a demonstration on a software tool called ENC Bathymetry Plotter. Some of you may have heard of it or seen it already. And finally, we will have some time for questions and answers. So using the panel of the webinar tool, you can submit some questions. We will pick them up so we can see all the incoming questions. And depending how much time is left, we can focus on some questions and share them with you and also provide the answers. And as always, we will collect all questions and send them as a follow-up to all the participants, including the comprehensive answers. Let's have a look at the new IHO standards. I said, these are the standards that have been relevant to us during our development activities in this year, I would say. So the S58 validation standard edition 6.1 was released in September, just a few weeks ago. S58 deals with ENC validation checks, so this is relevant for our ENC analyzer software. We'll provide some information about a new edition of the software later on. The use of the object catalog for ENCs, which is the encoding guide for electronic navigation and charts, has also undergone a revision. The latest edition was released in January this year. And then the highlight of the year, just after Christmas, is the S100 standard edition 4.0.0. At the moment, the member states are voting because we need member states' approval so that the IHO can release a standard. Associated with this edition is S101, the new generation standard for ENCs, and also the S102 standard, which is for the bathymetric surface. So, for example, gridded bathymetry. I can see that my colleague Pavel is getting a little bit nervous here. I believe he wants to comment on some of the things I said. Pavel, is there something that was not correct?
Hello, everybody. I just wanted to mention here that we are really excited about the new S101 standard coming in December. But my colleague wants to say most of the time that it's like a Christmas gift to us. But it's actually really important for you to know that it's actually just testing version that is coming out. And the edition itself says that, so it's 1.0.0, so it will be not really operational, but of course it's a really nice book for us to work with for the future. So please continue.
Okay, I had to find the microphone, got lost somewhere here. Yeah, so what Pavel is saying, it's probably not an appropriate Christmas gift, since S101 edition 1 still has a kind of test status, but I think it's an achievement worth mentioning it, and it's the basis for the ongoing tests that will be done. And there is a dedicated testbed group within the IHO S100 working group. So I think it's good that it's released this year. So currently, 7Cs is doing a maintenance session of the ENC production tools, and this will be ongoing until the end of this year. So basically, we are working on improvements, new features of our traditional ENC production tools, like, for example, ENC Designer, ENC Manager, S57 Writer, and so on. And the focus is clearly on requests and feedback from our customers, because those are the people that work with our tools, that do real serious data production. And so we are really happy to get lots of feedback. So our support department is doing a good job. They're always in close connection with our customers. And so this gives us a lot of feedback to hopefully improve our tools. Some of these features or these new functions are related to improvements of geometry and feature editing. So we have features which allow us to do advanced area and line feature editing. We have actually a nice function which is we call geometry snapping. Once I've read them all, I will do a demonstration, so don't worry. We also included additional automation tools which help you to automate specific predefined procedures that can be started from the graphical user interface or also from the command line. We'll also do a demonstration on that. There are improved optimization functions, especially for the S57 writer, and we are planning to include multi-user support for ENC Manager as well. There are more functions, more features, probably also some bug fixes. There's no software without bugs. And what I want to do now is to do a kind of demonstration, because Despite the fact that software has not been tested yet, I think we can show some of the new features already. When we did the session this morning, it just crashed a couple of times. So, but then we just could go on. Let's see if we have more luck this time. Okay, yes, I'm still sure that that's the best approach to demonstrate what these new functions are used for. So what I will do is I will call ENC Designer, and I've already loaded a cell in ENC Designer, which I kind of prepared to demonstrate the swapping function. What does it mean? You can see that we have some depth area here, and this line here, I think you can see the mouse moving is representing the existing coastline. There's a built-up area here, so I'm using the S57 object terms or object catalog terms. There is a land area in the background, and this yellow line here represents a new feature that we want to incorporate. So actually, the old shoreline is using this gray line, whereas the new feature we want to incorporate is represented by this yellow line. So with the old or older versions of ENC Designer, we would have to do quite a bit of manual interaction in order to update the links, the feature to geometry links, because this old coastline here, or the edge representing this coastline, is also linked to this area here, this depth area, but also to this restricted area we can see here. And this line is also linked to this land area and the built-up area. So if we change the shoreline just by including this shoreline construction, the one I'm highlighting here, this means that we would also have to update all these other features one by one, one after the other. And we thought, there should be a smarter way to do this. So we introduced a new function we called swapping. And there's one condition: swapping can be done if the old stretch of the shoreline is a new one, if they are connected by a node. That's not the case here. So this would be the first thing I have to do. I will just connect this new line with the old ones here. Do the same here. So now these are connected, and what I can do now, I can use the Geometry Manager, which is a tool which is integrated in ENC Designer, which allows me to interact or to control the geometry. So I can select the old coastline here, and then I can put it to a buffer. The items in the buffer can be highlighted here. If I go back to the browser view, I can select the new item and then want to do a swapping between both lines. So I can switch back to the buffer here and the browser here. And then there's a function which is called swap lines. And what we can see is that automatically the depth area here, the restricted area here, and also these land area, they have been updated. Now they are all referencing this new shoreline here, which is represented by a shoreline construction. So if I do a feature query here, I can see that the shoreline construction has been incorporated, and the old coastline has been deleted or has been replaced, and the geometry is still there. So this is what I would have to delete manually, assuming that there are no other objects linked to this one. Pavel, do you think I've described this scenario sufficiently, or forgotten something?
No, I just wanted to add that what you actually just said, that the line stays because the edge stays because it's without any connected object to it. So you basically don't see it in active mode, but you see it in combi mode, and you have to delete it manually when you're done with your work. That's the only manual part that you have to do. The rest is done automatically, which saves a lot of time for the users compared to the previous version of the designer.
Okay, so I deleted it, so I can see you like it much better. Yes, with respect to unreferenced lines or edges, there's a function ENC Designer which would identify all those. In this case, I just deleted it manually. There's another new function or feature which I would like to introduce, and this is referring to the snapping capabilities of ENC Designer. Snapping means if you move a particular point or vertex and you want to position it at the location of an existing item, then you can use snapping. The older version of ENC Designer would support snapping functionality, but not for all the geometry functions we can see here. So in the old version, for example, it was not possible to snap, for example, vertices or nodes and vertices and so on. This has been changed in this new version of ENC Designer, which also allows me to facilitate the process of updating this chart here. It looks similar to the example before, but the difference is that now we are also including area objects here. We are including different feature types. So this would be the shoreline construction. This is also a new part. It's a new coastline. And so in this case, swapping wouldn't work. Still, I do not want to do too much manual interaction here, too much manual editing. So what we figured is if the snapping functions, if we improve those, if we add capabilities to the snapping, this can be still be done very easily. So the idea is that rather than deleting the old items and inserting and replacing them with the new ones, what we do is we just kind of move the geometry of the old coastline and snap it on the new geometry of the new shoreline construction and the coastline here. And that's what we will demonstrate right here. So I will use the vertex snapping function first, and I will just take this vertex and snap it on this vertex. The same here. Then I will just take this vertex and snap it here to this node. And I will snap this one to this node, this one to this node, and again, this vertex to this node. At this stage, old and new geometry are not coincident yet, but all I have to do is get rid of these vertices that I don't need any longer. And now both lines, the old one and the new one, are coincident. They are still duplicated, but we also integrated one of the ENC optimizer functions, which allows us to get rid of duplicates. And now what happened is that we immediately updated all the areas that are associated with the, or that have been associated with the old coastline and which still need to be connected to the new shoreline construction here. I guess this also functions very useful, or in general, to have more flexibility when it comes to geometry snapping, also based on some requests that were passed to us or forwarded to us by our customers. Let me give you another example. These were the snapping functions. Now I have a function which is called clipping. So what I've loaded here is one of the ENC test data sets. I guess they have been compiled by IHO a long time ago. And I use it here for these for the next demonstration. So basically, we assume that we want to create a subset of this huge data set for maybe we just want to change the layout of our ENC, and we can assume that, for example, the layout has been defined somewhere, and we can just incorporate it or import it. So this bounding box I'm selecting here is representing our new layout. There have always been functions in ENC Designer to do clipping, but what we would have to do is we have to select the geometry, open Geometry Manager, select the individual items that form the clipping polygon. So also quite a bit of manual work. And I said that we added additional tools which can be executed from the command line, but that can also be integrated in the graphical user interface of ENC Designer. And so if I use this, I call it the clipper. If I execute it, then the clipper will use this polygon to automatically clip off all the items that are outside my my clipping boundary. I guess, Pavel, can you say some words or some explanations when it comes to the use in command line mode?
Yeah, thank you. I mean, this is really useful tool because you can use it also if you don't use the ENC Designer at the moment. So before that, you had to use the ENC Designer to cut, delete outside and inside. Now you can use this tool with command line and have a batch file with defined files which you like to cut and then use the data from these files. So you basically can use more files at once and make these things really quickly. So a lot of work is done automatically now with just one command line, which makes things really useful for the customers.
Okay, thank you, Pavel. So as I mentioned before, the clipping functionality as such has always been in ENC Designer, but now we have implemented ways to facilitate the use of these functions. And so far, all the clipping functions that were incorporated in Designer would always apply clipping to all the features. But there are situations where you do not necessarily, when you define a clipping boundary, clip all the items within this clipping boundary, but just specific ones. And that's another example I will call up now. So this is what I will probably call extended clipping or feature clipping. Different demonstration data set here. So we just assume that this pier here and the stretched area, that they are new, that have been added to our ENC data set already. And if I switch to the geometry mode, you can see that these yellow lines, they represent the new items, and the gray lines represent the existing items. So despite the fact that this new pier is already has been copied into my existing ENC, what you can see is that it hasn't been incorporated correctly, because it needs to be connected or with these contour lines. It needs to split up the contour lines. It has to break up, for example, this depth area, this depth area, and so on and so on. And this means that there was a lot of manual work involved. So in the old version, you would have to, with one of these geometry tools, manually click on each intersection. After we've done that, we would have to redefine the geometry that's associated with the individual area objects and so on. And yeah, I found this very annoying. And I guess when we do trainings, we always have an exercise where we incorporate such kind of feature in an existing cell. And yeah, the exercise actually was very long, just due to the fact that we didn't have the right function here. So Pavel, next time you do a training, this exercise will be a few seconds only. So how does this work? Basically, we can refer to a specific feature in our data set, which in this case is this pier, which is represented by a shoreline construction. And we can just call the context menu, and then all the feature items at the position I clicked to are listed. And what I'm interested in is this shoreline construction. And now there's a new context menu, which says cut, delete, outside. And then when I click on this, I get a list of all the items that are covered by my pier. And I just see, why is there a lake area?
Yeah, I would like to stop you here for a second. Sorry, but I think you pressed the wrong button. You used cut outside instead of cut inside. So you don't like to delete the whole data set. Please do it again. So that's why you see the lake here, which is somewhere in the data set, but not in the area where we have interest. So let's do this again.
Okay, I guess I did the same mistake as the day before when we did the test for the session, right? That proves that I'm not a good learner, obviously. So again, you can guide me here. So I select the feature object, which is the shoreline construction. That's correct, right? Okay, he's nodding. And then I select the function cut delete inside, right? Okay, I believe cut delete inside should be okay. And now when I get this list, I just have to focus on those object types that need to be broken up, lines that need to be broken up, and areas that need to be broken up as well. So there will be the coastline here, which is overlapped by this new pier. So I will select this one. There are all the depth areas I need to break up. The existing depth contours need to be split. There's a harbor area which probably covers the entire area of this demo cell. I do not have to break this up. It's still valid. I guess the land area should be broken up here, not the coverage object, which represents the extent of my data set. And so this should be it. And what you can see that automatically all these lines have been split up, nodes have been created, so everything gets connected here. And this was quite a bit of work, manual work, as I mentioned before. What I can show here is that if we click on this depth area, you see when we select the geometry, now this in the original version, there was one big drying depth area. Now it's been split up automatically. There's one here and another one here. It's a bit difficult with one monitor only. And there's another one here. So we think this is actually a great convenience functions, one of the great convenience functions we included. And so we would have to do the same with this dredged area, which at this moment is still overlapping the depth area. Both are group 1 objects, which must not overlap. Actually, we can do it right now. Now I know how to do it, since Pavel told me. So I will select the dredged area. But now again, I have to think. We do the cut delete inside, right?
Inside.
Okay, so we would do a cut of the depth area. We don't see much of a difference. The reason is because there was no geometry we needed to split, so no edges needed to be split. It's just the associations of the spatials to the feature object that have been updated, and we can visualize it when we select the geometry of our depth area here. Now we see clearly that this part has been excluded, no overlap between this stretched area and this depth area anymore. Okay, I'm just thinking, do we have more exercises? Pavel, what?
Yeah, first to say something more about this. I mean, this was really horrible work before, and now it's like the possibility to make a mistake during your work and then try to find the errors was huge before, and now things are really simple with this new function, and as you said, done in a few seconds. So I'll probably have to think of another schedule for my training for future. Yes. Yeah, I think we can continue now with the presentation. Yeah, should be enough for now for the ENC designer. Let's see how we go on.
Okay, thank you, Pavel. So I just have to go back to the presentation. Let's have a look. That was the last thing we did. We had a look at the new features and functions, or some of the new features and functions, especially in ENC Designer. Next topic is the S100 plugin for FME. This morning, actually, we had a question, what does FME stand for? It stands for Feature Manipulation Engine. And the Feature Manipulation Engine is not a tool that's developed by 7Cs, but by the Canadian company Safe Software. But many years ago, we recognized that this is a great suite of tools to do data conversions, to do data analysis. And what was missing when we were looking into this tool was an S57 export function. So we asked the company and said, okay, will you support it in the future? And they went like, no, but we have a nice plugin interface. You can create an S57 writer. And that's what we did, but that's a long time ago. Now we're actually talking about S101. So we recently also developed an S101 import capability for FME. And when you look at this graph, you can see on the left side a list of formats and that you can read with FME. And on the right side, you see a list of formats that you can write with FME. So which means you can literally convert anything from the left side to the right side. Those items that are shown in orange are those readers or writers that have been provided or will be provided by 7Cs. So what's missing here is the S101 writer on the right side. But if that's ready, you can imagine that you can read S57, write it to S101, read S101, write it to S57, read a DXF file, write it to S57 or S101. So the FME comes with a graphical user interface, which basically lets you design your conversion flow. And once that has been done, you can script it, integrate it in your existing production processes and so on. So some of the participants may be familiar with FME, but this time I'm giving a bit more explanation since we had the question earlier what FME is about. So if you start the FME data viewer and you use the S100 plugin, you can read an S101 data set. And on the left side here, where usually the layers of geographic data are shown, all the representations of the feature classes are shown here. Here in this graphical window, the data set is displayed. You can influence the appearance of the data. So this data viewer does not use any standardized symbol instructions, for example, like S52, because the intention is just to do a quick review of the data before you set up your processing workflow for the data. Some of you may have attended the very first session where I introduced some of the new particulars of the S100 standard opposed to S57. And one of the examples I gave was the cardinal buoy, which is a good example to explain, first of all, the multiplicity of feature attributes and also complex attributes. When you look at this cardinal buoy, an S57 encoder would have to use the attribute color and then write or type black, comma, yellow, comma, black, just one single attribute. Now in S101, we can see, and I will check if you can see in my mouse moving, the attribute color appears 3 times. That's referred to as multiplicity or cardinality. Then in S101, this top mark is not an individual feature by itself. It is an attribute of the cardinal buoy. And this top mark has, let's call it, sub-attributes describing the shape and also the color of my top mark. And this structure is actually also represented in the S101 reader plugin for FME when you do a data query. So at this stage, the S101 plugin supports the underlying data model pretty well. So it's not just reading the data, it's also when you do a query, the data model is reproduced here. So what can you do with this S101 reader for FME? Well, first of all, it's an additional format for FME. When you buy FME, it's not supported, so you would have to use this plugin. The good thing is the S100 reader plugin will be for free, so it doesn't cost anything. Along with the other tools which are undergoing the maintenance sessions, will be released probably Q1. The other tools will be released Q1 next year. We hope to also include the S100 reader into this. You can, as we've seen it before, import and display S101 data. And what might be of interest for those organizations or people that are already interested in getting familiar with S101, or those organizations that want to participate in the S101 test bed that's still ongoing. We can use this reader and FME also for data analysis of features, attribute queries, and so on. And out of the box, we can also use it for data conversion. So if we have S101 data, we can convert it to any of the formats that's supported by FME. And we can also, maybe not a use case of today, but also do a backwards conversion to S57. So this might be relevant if S101 data is available, but not all end applications do support it. There will be a new release of our ENC validation tool analyzer, and that will be the version 4.0.0. The graphical user interface has changed slightly, but I guess it still looks familiar. On the left side here, there is the navigation pane, which lists all the data sets that have been loaded. We have a report here on the right side, which shows all the findings, the errors, and the warnings. The new analyzer is based on our Nautilus S100 Actis kernel. It can be used to validate S57 ENCs and IENCs. The next update then will also support AML, for example. Very important, it includes the new S58 6.1 edition, which was released last month, and also the IENC validation checks. As before, it integrates into the graphical user interface of ENC Designer, And since it's based on our Nautilus S100 kernel, it also includes an additional module for S101. The analyzer is known to some of the participants of the S100 testbed already as validator. We provided it for free to support the development of S101 validation checks, which do not exist yet. So what the validator and the new analyzer, what it can do, it can read an S101 data set, apply obvious checks which refer to the data structure, naming conventions, things like this, but also some of the S58 checks are so obvious they will be adopted for S101 validation. So in this respect, Analyzer is also a tool which assists the working group that's developing the validation standards in doing this. The release is scheduled also for Q1 2019. So this was a lot of information about new tools, and now the last part of this session, in this last part, I would like to draw your attention to an issue or a topic that has been discussed at many occasions during IHO working group meetings on different levels that have been, that took place last year or this year, and the topic is high density bathymetry. Let me show you what this is about. If we look at an ENC or at the bathymetry in the ENC, and especially at the contours, we will usually find the contours at 0 meter, 2 meter, 5 meter, 10 meter, and so on. And if such a data set is loaded in an active system, like shown here on the screen, and when the safety contour setting of the actis is set to 10 meter, then in the display, the corresponding contour line, the 10 meter contour line, will be kind of highlighted or shown as a thick black line, which means for the operator of the ship, don't cross this line, because if you cross this line, it's too shallow. So if you need 10 meter, don't cross this line. If the situation is slightly different on board, and the captain says, oh no, 10 meter, we need, what we need is 11 meter, that would be the appropriate safety contour value, then again, the active system will try to retrieve the corresponding contour from the chart. But as we can see here, there is no 11 meter contour in the chart. So it will pick up the 20 meter contour, which exists in our data, and display this as the safety contour, which means that the channel has narrowed much more than really required. We zoom in here. This part, you can see there's a 10 meter contour, there's a 20 meter contour, which is now shown as a safety contour. But actually, if the active system or the ship just needs 11 meter, then why should the 20 meter contour be my limit? Actually, I could go beyond. But the ENC doesn't have this information. So this is why they don't go beyond the 20 meter safety contour. And the area that's highlighted here is kind of lost navigable area. To overcome this problem at all these meetings, and also the IHO is encouraging the hydrographic officers to include denser contours. Because if we create ENCs with high density contours, it would be much more appropriate when we do the safety setting in the actives to find the corresponding, or it would be possible to find the corresponding contour. Why do hardly any hydrographic officers produce high density ENCs? There are different reasons. Still, there are an interactive manual process involved in creating these contours. creating contours at this density can create issues with the topology. For example, the more contours you have, the denser they get. They may create intersections, they may touch each other, so the topology may get corrupted. So if you have a few contours only, it's much easier to handle. But still, we see that the active users, they have a demand for high density contours. So our answer to this problem is ENC Bathymetry Plotter, a tool which allows you or supports you in the creation of contours and selected soundings for incorporation in nautical charts. And I've also prepared a little demonstration for this. So I will start ENC Bathymetry Plotter. That's a graphical user interface. So basically what we do, we load a data set. In this case, it's an XYZ data set. And Pavel, you have a question again, right?
No, actually, I want to add here because I can see that you're talking about the data formats that this software can read. Is actually not only XYZ files which can support this piece of software, but also BAG files, S102 files, S3 ASCII grid files, NetCDP files. So we have a bit range of files which can be supported by this software, and of course you can easily export them later to the contour lines in BNC.
Thank you, Pavel. Yeah, that's a good point. But the procedure is always similar. The first thing we need to do is we have to read source data, input data for our tool. Once we've done this, the data will be displayed in the display here of the Bathymetry Plotter. It allows us to specify some more parameters. Most important one probably is the coordinate reference system. That's required for the coordinate transformation when we do the export to S57. So we have a few options to manipulate the display. We can do shading here, for example, which gives us a nice a picture of the structure of the sea bottom here. So we can, it gives us a good impression of this channel here. The next step would be to generalize this model and to create a nautical elevation model. There's a special tool we can use here, and we can control the degree of generalization. If I go to the very end here, you can see the generalization is, it's a big generalization. Actually, what happens, the gray line here shows the profile, whereas the blue line shows the result we will get after the generalization. So the smoothing of the model is always shore biased. That's very important. So what we want to do is we want to generalize and smooth our very detailed and rough model rather than smoothing contour lines after the contouring process. So we've created a nautical model now, and if we switch between the model view and the original view, you can see that the degree of details is decreasing in the model, which automatically allows us to create much smoother contours. Next step is a contour generation process. Nothing special. You just specialize here or define the contour levels, and you run the process. And depending on the size of the data set, this may take a little bit. Now the contours have been created already. I can switch off the shading, specify some other parameters here. So now I can see that these contours that this results in quite nice and smooth contours. What I also want to do is I want to create some selected soundings. I specify the spacing of the soundings, so then the soundings will be added as well. And the next step is that I export everything to S57 in case I want to incorporate it into an ENC. In this dialog, I specify the details of my data set. One thing that might be interesting, it reads product, so I can decide if I want to create it as a BENC or an ENC. A BENC would be a separate bathymetry layer that is very popular in PPUs. But in this example, I will create it as an ENC because I want to use the data to incorporate them into a traditional ENC. So I will run the export process. And then after I've done that, I can load the data and review it again in ENC Designer. We'll remove this and import my data set. Actually, you can see that this data set was just created 1750, which is coincident with my system time. You can also see it. So now I'm really loading the data set I'm just created, and I'm excited to see the results. What you can see that ENC bathymetry plotter not only exported the soundings and the contour lines, but it also created the depth areas. And actually, that's the tricky part, to get this right. Not only to get the attribution right, which is relatively easy, but to make sure that all the polygons are close, that we don't have intersections, and so on and so on. What we would do now is that we want to incorporate this data in our ENC, and I guess, well, with 10 more minutes, I can do a quick demonstration here. So I will load the original ENC of this area. This is the situation before I probably did the new survey. What I want to do is I want to remove the existing bathymetry and replace it with the new data. Actually, again, I can use one of my new clipping functions, because what I do is I can do clipping based on a specific feature type, which in this case would be my coverage object. And then I run a cut delete inside. Pavel, I think it's always cut delete inside. Why is that? Well,
it's not always, but in this example, yes.
Okay, good. Okay, now what I have to specify is those object classes that represent bathymetry, which in this example would be the depth area, the depth contour, and also the soundings. And now the bathymetry is gone, and now I can include the new bathymetry file, which is this one. And as you can see, I have to copy it into the base file here, and you see that it doesn't really cover enough, or doesn't have enough data. So this would be the part where I would have to do some manual interaction to knit this into my original data set. I guess presentation and demonstration wise, I have covered everything, and I'm not sure, but I can see that we've received some questions, and so let's have a look.
Yeah, thank you for the presentation and demonstration. That was really nice. We didn't have any accidents, which was good, and still test version of the software, which makes me confident that it will be the final version will be doing a good job. So there is one question which I would like to emphasize, which came actually this morning. I think people would be interested to hear also this question today. And yeah, somebody asked if 7Cs is already working on development on S100 based products. And yeah, this is a really nice question, and at the same time really difficult question. And first of all, to answer, the answer is yes, definitely. we always want to follow the latest standards and develop cutting-edge technologies. But there is always but, and I mean, we know that at the moment the S100 based standards are being developed, and some of them are not really fully operational. And as my colleague Friedhelm mentioned, that S100 standard is at its edition 4.0, and now we have nice book to work with. But regarding the S101 standard, which is kind of equivalent to S57 standard, the testing version is expected to come out by the end of this year. This means that starting from next year, we will already have some more serious documentation to work with, and we can even further develop our S100 based ENC tools. But nevertheless, so far we've developed our Nautilus SDK Actis kernel system, which is based on S100 standard and is used as development basis for our existing and future ENC tools. For example, you already mentioned these tools, but S101 Reader, which is the plugin for FME, is already available and can be used to load and analyze S101 data format. The new analyzer is also based on our Nautilus SDK, and at the beginning will support S57 file formats and S58 validation checks. So this software will be released around Q1 next year. But which is more important for the future is that this software will also support some more obvious validation checks for S101 standard. Why do I say obvious? Because the answer is simple again, and it's related to S101 standard and missing part the validation checks for the standard, which are still not developed by IHO, and we are actually supporting them in this matter, and we will use also our analyzer to support the development of this standard. So we basically learn in parallel both institutions. So to summarize, in other words, our products are actually knocking on S100 door because we already use our new Nautilus SDK system for the development of our tools, which allows us to easily adopt the software in order to support those standards. And of course, this can be done only when all standards are in place. So I hope this makes things a bit clear for everybody how we plan to go in future. And yes, any other questions maybe coming in, Friedhelm?
Yes, there are some other questions, and there's a question. I think it's related to ENC Designer because that was the tool we were using for the demonstration mostly. The question is if it can read shape files and to as a basis to incorporate new features probably. The answer is that we have a specific approach when it comes to the incorporation of other digital formats. This is what we use FME for. FME can read all these formats, and we can use the FME conversion capability to translate everything into an S57 compatible format. Just reading a shapefile, for example, doesn't help us much. What we also want to do is we want to assign to an individual shapefile layer, we want to assign a particular S57 object class. And that's what we can do in the FME and with the S57 writer. And then the results of this conversion can be read in ENC Designer. Let me think. Alex, do we have time for more questions?
No, Friedhelm, I think we are quite over with the time, and I want to thank you both for the brilliant presentation. yes, dear participants, thank you for listening. We hope that you enjoyed the whole series as much as we have preparing it, and we wish you a nice day or evening or wherever you are. Yes, thank you very much and good evening.